Bismillahirrahmanirrahim and welcome to Rahman Digital Production. This is lecture number 8 of Physics 5054. Today we are going to discuss the practical application of velocity time graph. Ladies and gentlemen, you must have to keep in mind that we can get a lot of information from the graph. From numerical data, we cannot get that sort of information which we can get from the graph. So understand how we are grabbing information from the graph. Graph means the pictorial representation of data. Pictorial means that picture. Okay, there is a work example on page number 25 at the bottom. We are going to discuss this graph. This is given, and then we will find the distance. There are two methods of specifying, getting the information from this graph. Ladies and gentlemen, let us first understand the question and then we will solve it. The question is saying that a bullet train starts from rest from a station and travel along a straight horizontal track towards another station. The graph in figure 2.13 shows how the velocity of the train varies with time over the whole journey. Using the graph, determine the total distance covered by the train. Yesterday we discussed that if we want to find the distance, we have to find the area under graph. Velocity time graph, if we are finding this area, then we will be able to get that how much distance this train has covered. Now there are two methods. I am doing it on method number 1 and I will do it on method number 2 as well. So first let us discuss method number 1 and then we will turn our focus to method number 2. If you give a look to the figure, then it is a trapezium. What is trapezium? There are two parallel sides, which is this one and this one. And there are two non-parallel sides. So the formula for area of trapezium is equal to 1 over 2 into height into sum of parallel sides. Sum of parallel sides. So I am writing 1 over 2 and there is a height of 40 because you can see the height of this trapezium is 40. And then the sum of the parallel side, that is from 2 to 16, yani 16 minus 2, that is 14, plus, and that is 2, and that is 12 minus 2, that is 10. So if we further simplify it, we will get the 2 ones are 2, 2 20s are. So in this case, we will get 20 into 24. 20 into 24, because this is 16, this line from here, so it is 16 not 14. It is not starting from here, it is starting from the origin as asked by the question. So 16 and 10 here, from 0 till 16, 16 minus 0, and this line, because these are the two parallel lines, the length of this line is till 12 and 2. So when we subtract 2 from 12, we will get 10. So this will be equal to 6. 26 and 20. So when we multiply 26 by 20, so 512. Well, let me explain here that area is always represented in meter square, but because we are finding the distance and the method says that you have to find the area under the graph, then that will be equal to distance. So we have to write 520-meter distance this train has covered while moving from one station to another station on a horizontal track. That was the first method. We got this answer. Let's turn our focus to the second method. We have to divide this whole area into three parts. One part is this one, the first I am and labeling it, and this is the second, and this is the third part. The first and the third parts are triangle, and the middle one is a rectangle. So first we have to find the area of part 1, and you know area of triangle is height into base. So this will be equal to 1 over 2, and the height of this triangle is 40 and the base is 2. So this 2 will be cancelled with this, and this will be 70 meters square. Now the area of part 2, area of part number 2 is equal to length into breadth. Now the length of this is 12 minus 2, so 10, and the breadth is 40. So it is equal to 400 meters square. Now area of the third part, area of the third part is again a rectangle. So we have to use the formula of rectangle. You can write it base into height or height into base. Because it is multiplication, so order doesn't matter. 1 over 2, and what is the base of this 16 minus 12 mean 4? Multiplied by 4, and what is the height? Again 40. So 2 twos are, and that will be 80 meters square. Now we have to add all these three areas, and we will get total area is equal to 40 plus 400 plus 80 meter square, and again we will get in this case 520 meter square again. But as I told you, meter area under the VT graph is equal to distance. So we will take this as distance, and that is meter. So in both the cases, you are getting the same answer. Whatever method is feasible to you, you can use that method. If it is easier, in my view, this one is easier. But if you want to do it separately from different students, so you can do it on this method. Okay, there is another very important piece of information we can get from the graph. The velocity time graph of a car is shown in this graph. We have to grab the information from this graph, that what sort of motion this car is having at different time intervals. So let us start from the 0 second, from 0 second to 5 second. What is the motion of this car? Because from 0 to 5, this is a straight line, so it means that motion, the velocity is changing uniformly, so there is a constant acceleration. Constant acceleration, uniform velocity and constant acceleration. Uh, if we want to find the acceleration, so we have to find the time, which is 5 seconds, and we have to see that how much 15 minus 0. Acceleration is equal to rate of change of velocity with respect to time. So 15 minus 0 divide by 2. 15, by 5, because the time interval from here is 5. So it means 15 divided by 3, which is equal to 5 meter per second square. Now in this region, it is having an acceleration of 5 meter per second square. Now we are turning our focus from 5 to 10. From 5 seconds to 10 seconds. What will be the motion of this? You can see that the velocity is increasing. It is moving in upward direction. Velocity is increasing. Velocity is increasing. And acceleration is decreasing. Is decreasing. The acceleration is decreasing. You can see that from the graph, that it is decreasing. It is a curved line. Velocity is increasing, but the acceleration from the graph we can observe that it is decreasing. So this information we can get from 5 to 10. Then it is the turn of from 10 second to 15 second. If you see that there is a straight line, there is a straight line, there is no change in the acceleration. The acceleration is neither increasing nor decreasing, so we are calling it at constant velocity. Uh, Velocity is constant and acceleration is zero. There is no acceleration inside it. Neither it is decreasing nor increasing. So in this particular area, if we look, there is a straight line. So it means from 10 to 15, its acceleration is zero. Now we are turning our focus to the next one, and that is from 15 to 20. From 15 seconds to 20 seconds, what we are getting. What we are getting from 15 second to 20 second. You can see, ladies and gentlemen, that this is a straight line and it is going downward. So it means that acceleration is decreasing. From 15 to 20, the acceleration is decreasing uniformly. The acceleration, the velocity decreased uniformly from 20. So it means that retardation can be observed. Velocity is decreasing uniformly. So retardation or negative acceleration can be observed. Can be observed. And this is the situation for 20. So it means that acceleration here will be from 0 minus 20 divided by 16 minus 12, 4, which is equal to minus 20 divided by 4, which is equal to minus 5 meter per second square. Minus means retardation, negative acceleration. So here is the case. What we are observing from 20 to 25, from 20 second to 25 second. You can observe that there is a straight line. So it means that the car is at rest. Velocity is zero. Here velocity is zero. So the car is at rest in this area. From 20 to 25, that is a straight line, zero, because it is on the horizontal axis, so it means velocity is zero. When velocity is zero, it means that there is no acceleration. So it is at rest. Now from 25 to 30, from 25 second to 30 second. You can see that the velocity is increasing uniformly. The velocity is increasing uniformly. So constant acceleration will be observed. Velocity is increasing constantly. Sorry, uniformly I should write. Uniformly. So the acceleration in this region is constant. The acceleration in this region is constant. Now finally we can see from 30 to 35 that it is a curved line. So retardation will be observed but not constant retardation, because it is variable velocity. The velocity is decreasing variably. The velocity is decreasing non-uniformly. So retardation will be observed. Here from 30 second to 35 second, actually what we are observing, we are observing that velocity is decreasing non-uniformly. Non-uniformly. So from 30 seconds to 35 seconds, we are observing we are observing retardation or negative acceleration. So you saw, ladies and gentlemen, that we can get a lot of information from the graph. Whatever the graph is shown to you, you can get different information from the different line styles. There might be a straight line, there may be uniform acceleration, there might be non-uniform retardation. So we saw that we can get different information from this. Now we are turning our focus to another very important topic, and that is the uh, acceleration of free fall, which is represented by small g. Okay, the topic is acceleration of free fall, for which we are using the small g. This is very important in our daily lives as well, which is affecting our daily lives. So we have to study the acceleration of free fall. The acceleration due to gravity is another name given to it. The value of g, to be very much exact, is 9.8 meter per second square, and it is constant near the surface of the earth. It is not changing. About 1 kilometer above the surface of the earth, if we are observing different activities, then we will take that is 9.8. But for simplicity, in your book and many other books, they are taking it 10 meter per second square, which is very, if you are rounding this 9.8, exact value is 9.8, but because for students in the calculation difficulty arises, so they are taking it 10 just for simplicity. If you want to get the more accurate answer, then use 9.8. But for this course, in the remaining chapters of this book, we will use 10 meter per second square. Now we are observing that there is a feather which is very lighter as compared to the hammer. What do you think that if we are dropping feather and hammer at the same time, which body will reach the earth quickly? It is common observation that the hammer is heavy. There is a more force of gravity, the force of gravity on it, not the more constant gravity 9.8, here also 9.8. But scientists are saying that these two will reach the surface of the earth at the same time if we are performing this experiment in vacuum. If you remove the air from a hall, big hall, then both of them, because air resistance will not be there, that is why we are saying free fall. Freely it will fall. No object will be a hurdle for the feather and hammer in these cases. Feather and hammer. So if air resistance is removed, both the feather and hammer will reach at the same time to the earth. And let me tell you, just search on the internet. There is an experiment. See the video. There is a big hall in which this experiment is performed, and then you will see that how both are reaching at the same time. For that you have to use YouTube. There are videos. Search it and see it. If we are going to explain it, then it is saying at time t is equal to 0, both W1 and W2 are at rest. Here you can observe commonly that W2 is greater than W1. Feather is lighter and the hammer is heavier. So here we have written at rest. If you are keeping it, you will feel that hammer is heavier than the feather. When we release it from this height, and after 1 second we observe the motion of these, because I told you that both of them will have the same motion with the same speed. then they are reaching to this position, and we are saying that this much displacement they covered, and we are denoting that with S1. So this is the situation after 1 second. The velocity v1 is observed 10 meter per second, and still the weight is the same, that is W1. We are not changing or labeling it to W2 because the weight remains throughout the same. And similar case is with the hammer, that is W2. What we are observing, that displacement is 2 is greater than the displacement of S1. Here the velocity and here the velocity is changing. So it means that we are observing acceleration, and that is due to gravity. What is gravity? The force with which the earth attracts a body towards its center. That is called gravity. So the displacement S2 is greater than this S1, and you can observe this from the length of this displacement. At time t 2 second, velocity v2 is again 20. It means that first it was 10 and now it is 20. So 10 change is observed. And that the weight is again W1 and the weight again here is W2. The thing which we are observing is that displacement S3 is greater than the displacement of this S2. S2 displacement is smaller and S3 displacement is greater. So it means more acceleration is observed. Now at time t 3 second, velocity v2 is 30. It means from 10 to 20 means 10 difference. From 20 to 30 means 10 difference. So we are observing different things inside this, and that is written in the book, and let us study it. The following deductions can be made. Both the feather and the hammer increases their speed at the rate of 10 meter per second every second. That is, they undergo a constant acceleration of 10 meter per second square. The second observation is the direction of this accelerated motion is downwards towards the center of the earth. I explained it. The third one is the acceleration doesn't depend on the masses or the weights of the falling bodies. In other words, all objects, whether big or small, increase their speed at the same rate. This motion is represented by the velocity time graph, and it is given it like this. Let me make a graph of this. I'm making it a smaller one. This graph, it is 1, 2, 3, 4, 1 second here, 2 second here, and 3 second, which is at the bottom. Now there is 10 because we know that it is 10 meter per second, and then 20 meter per second I wrote it from here, and then 30 meter per second, and I wrote it from this one. Now there will be a point here, and there will be, because this time n velocity, this is velocity meter per second, and this is time per second. So the second point will be here, they are intersecting each other at this particular point. The third point will be here. So if we divide this time, this velocity with 1, it will get you 10. If we divide 20 by 2, it will also yield 10. If we divide 30 by 3, it will. So it is a constant acceleration. And this is denoted by a straight line. Remember, when you are getting the straight line, it means that with the increase of time, velocity is also increasing, and you can observe these from the displacements because they are covering more displacement. So it means that it is a constant. So 10 divided by 2 is a constant. I think enough for today. Tomorrow we will discuss more topics inside. In fact, we will do the exercise as well. So thank you for watching. Please subscribe my channel and share it with your friends and family members to support me. Press the bell icon so you will be notified when I upload a new video. Thank you very much. Allah Hafiz.